configurational isomerism and conformational isomerism. Hello everyone, welcome back to PLUTUS STEM. So today we are going to discuss a very important topic of this isomerism, the stereoisomerism. In this topic we will discuss what is stereoisomerism and how we can classify these, how many type of different stereoisomers are there, and what is the difference between the isomers, structural isomers and the stereoisomer. That's the thing which we are going to discuss in the today's lecture. Yeah. And one more information which I want to provide you is that we have already covered up the various structural isomers such as ring isomers, chain isomers, positional isomer, tautomers and metamers. All of them have been covered. You can go through them. The videos are already been uploaded regarding all the structural isomers. So in the today's class we will be discussing a bit regarding this stereoisomers or stereoisomerism. So the first thing is that this is a subpart of structural isomers. This is our isomerism I have discussed. And this isomerism we have subdivided that into two parts. One was the structural isomers and another is the stereoisomers or stereoisomerism. So what is the basic difference between these two type of isomers? That was that this isomerism, I have already told you in the previous video, you can go through that also, that this isomerism is a phenomena where we are having two different compounds that are having the same molecular formula and different structural formula, or either structural formula is different or their sequencing is different or their orientation is different. Either their structural formula is going to be different, or we will see their sequencing is different, or we will see their orientation in 3D of the atom present in the compound are different. So here we are going to see that this is not the general rule for this. These are the properties which we are going to see. So what is the basic thing regarding with isomers? So isomers are basically those compounds that are having same molecular formula but different chemical properties. Same molecular formula but the different chemical properties. And gradual increase in the you can say some physical properties also. Yeah. So coming back to this, I have just told you that these are like structural formula may be different, sequencing can be different, or orientation in 3D can be different. So here we can see over here that if we are having such type of compound CS3, CS2, CS2, CS2 and CS3. So the compound's molecular formula is 1, 2, 3, 4, 5. 5 carbon are there and 12 hydrogen are there. C5H12. And in this compound, if you see, they are sequenced like this. 1, 2, 3, 4, 5. All the carbon sequencing is like this. If we alter the sequencing like this, so this one and this one, these are different structure due to the sequencing. Here we are changing the sequence of these carbon chain. This carbon earlier it was attached at this side. Now we are attaching this at this position. So sequencing we are changing. So this can be for any element. We can see somewhere we have already discussed various isomers. In metamerism we were just changing the sequence of a polyvalent group. In positional isomers, we were changing the position of various functional group, double bond, triple bond, and alcohols. Sorry, double bond, triple bond, and like some branches. So that was in the positional isomers. So in the functional group isomers, we were changing different functions. So this was the basic thing. Over here, the sequencing is big change. But regarding this stereoisomers, now coming back to our main topic, stereoisomers or stereoisomerism. So what will be the special over here? These compound, they don't have like this: CS3, H, C2H5 and C3H7. If we are having a compound like this and we are having another compound that is again CS3, carbon, hydrogen, C2H5 and C3H7. These are two different compound or same compound. So if you see over here, this is CS3, over here CS3, this is C2H5, this is C2H5 below the plane, this is hydrogen above the plane, this is hydrogen above the plane, this is C3H7 above the plane, this is C37 above the plane. Sorry, yeah. This has to be on the plane. Let's say if it is above the plane, this is on the plane, and because it is not possible, I will just tell you this thing also here. So like this we can represent. So this is the way how we have. So now these are same. So everything is same in this compound. This compound and this compound, they are having everything same. So these are same molecule. But if we make a slight change, CS3, hydrogen, at this position, if we are taking this C2H7 and here C3, C2H5 and C3H7. If we are making such type of arrangement where the orientation in 3D is different, so these two are stereoisomers. Here we can see the connectivity is now also same. So this C2H5 and this C3H7 now also connected to this carbon one only. But their orientation in 3D is different. So that's why these two are stereoisomers. So this type of isomers, we are going to first classify those isomers, how we can classify this orientation also in 3D. So these stereoisomers, they are generally classified into two classes. Over here we will see this compound, they are going to have molecular formula same or structural formula same, connectivity same, orientation different. Orientation will be different in 3D in all these stereoisomers. So now what are the major difference between the first two subclass of this stereoisomer, that is configurational isomerism and conformational isomers. Configurational isomerism and conformational isomerism. So here what is the thing which we are going to see over here? The major difference between these two is going to be, there will be a difference in the orientation. There will be the difference in the orientation. In this conformational isomers, we will see the rotation around a single bond. This different orientation will arise due to the rotation around a single bond. So if I see you one, I will show you one example. Let's say this is our carbon 1 and these are the 3 hydrogen, and if we take another hydrogen that is below the plane CS3, this compound is C2H6, and if we rotate this, some rotation takes place over here. If some rotation takes place and this compound moves like this, these are the 3 hydrogen, and this hydrogen moves and comes over here. This hydrogen moves and comes at this place, and this hydrogen after movement comes at this place. So you can see these two are oriented in different 3D orientation. This one and this one, they are quite different. So if I would like to show you how these are being orientated, then this is like this orientation is like this. So 3 hydrogen are like this, and after the movement they became like this. So they are like this. The upper one 3 hydrogen, they are shown like this. So after a bit movement we are making them like this. If you can visualize over here, this hydrogen, these are like this, and regarding this one hydrogen, the upper one, if you see the below hydrogen, they are like this. Below hydrogen they are like this again, the back one also, like clear or not. And after the rotation, this one hydrogen, if you see, this is the this one hydrogen, it is rotating like this, it will become like this. Can you visualize over here or not? So this type of rotation, so this is one carbon and the same thing is at the backside carbon. So this one carbon CH1 H2 H3 and the same place at the another carbon CH1 H2 H3. So this carbon is coming forward to this. So this carbon hydrogen are not that much shown. When they are coming like this side, then we can visualize these hydrogen. So this is the way how the rotation around this carbon-carbon single bond. These type of isomers, they are being shown when the simple rotation around carbon-carbon bond takes place. So this type of isomer or different orientation that is being observed, they are termed as conformational isomers. So we will study regarding this conformational isomers in a separate video in quite detail regarding, this is just our ethane. We will see regarding propane also, butane also, and hexane also, like we will see different chain isomer, boat conformation and chair conformation, that all we are going to study regarding this conformational isomers. So if you see over here, this one is staggered and this one is eclipse. And generally if you see over here, this isomers is more stable. This staggered isomer is more stable. This staggered isomer is quite more stable comparable to this eclipse isomers due to this hindrance of this hydrogen. Both the below one hydrogen and the upper hydrogen, they are in the same plane. But after this rotation, they are like this. So you can see over here that this staggered and eclipsing, if you will see over here, that this is more stable conformation and this is a less stable conformation. And generally these are not isolable, which means it is not quite easy to isolate these different isomers. So generally we cannot isolate this compound, but these configurational isomers, they are isolable. It means we can isolate them, we can have them separately. Generally these cannot, because there is a rotation around a single bond. It is quite difficult to isolate those conformational isomers. And the second one is configurational isomerism. So these configurational isomers, we will see this type of isomer, they are being shown due to a 3D orientation. The different 3D orientation and this type of isomers, they can be isolated. These can be isolated, and these are two different separate compounds. So this type of stereoisomer, what is the basic principle over here? In this configuration isomer, we will see all things are same, but the orientation in 3D is different, and they are here we are saying the rotation around a single bond, and here we will see they are not arise due to this rotation around the single bond. These are two different molecules. So generally these configurational isomers, they are of two types: geometrical isomers and optical isomers. Geometrical isomers and optical isomers. So two major class of this are geometrical isomers and optical isomers. So this the main thing about these two difference is there. These geometrical isomers, they give rise due to the restricted rotation. These arise due to the restricted rotation, and generally the restricted rotation is being shown in the double bond in the cycle, like this cyclic compound. So if you see over here, if this one is hydrogen and this one is hydrogen and another hydrogen is like this, so this one and this one, if you visualize over here, sorry, so this one two are same side and these two are at the different side, where we will see that there the distance is different. You will see a difference in their length between these two atoms. So this type of isomer, geometrical isomer, this arises due to the difference in 3D orientation when we are having a restricted rotation. The atom present at a restricted rotation carbon or moiety, and they are at the same side or sometimes they are at the different side. So this type of compound, and sometimes if this is hydrogen upside, fluorine below side, over here fluorine upside and hydrogen below side. So this fluorine below side, this fluorine above side. And the another possibility will be the opposite of this, where we will be having fluorine upside both the time, like this. So these are two different geometrical isomers that are arise due to the presence of different orientation, but at a restricted rotation carbon. Generally these type of isomers we study at a double bond or alkene, but they are being shown in this cyclic compound also, and some many more compounds are there in which we can see this type of geometrical isomers. And regarding these optical isomers, these are being shown when no restricted rotation. So no restricted rotation is there. So these compound can rotate around their axis. So there is no restricted rotation. So here the restricted rotation is there. Here the no restricted rotation is there. So this type of isomers, they are again subclassified into enantiomer and diastereomers. They are again classified into enantiomers and diastereomers. Enantiomers and diastereomers. And it is not that sometimes we can have some other type of classification also, because the classification is just to understand the concept. Like if you are having all no classification is there, so it will be quite difficult to understand all these isomers. So there are enormous number of isomers are there. So we classify them so that we can learn them quite easily. So don't be confused if you find somewhere a bit difference in this type of classification. It is just the different way to classify Like we have to classify the organic compound. Sometime we will classify as benzonide, non-benzonide, and some other will classify as a heterocyclic and homocyclic, then they will subdivide that. So this type of subdivision you can see a bit difference, but the major thing over here is just to memorize these isomers on the basis of this classification, so that it is quite easy for you to understand or memorize all these isomers. So I have just made it very simple for you. That firstly, we have already discussed regarding the isomers. The difference between isomers and stereoisomers is that the isomers are those compounds that are have it's structural isomers, and you can say structural isomers and stereoisomers is that they are the isomers which are having only difference in molecular formula, or sequencing, but these are due to the difference in the 3D orientation in space. Difference in orientation in 3D or space. So in this we have classified these. The first classification is configurational, another one is conformational. For configurational we have seen they are isolable and they are not isolable. They are not isolable. We cannot isolate these compounds. It is quite difficult for us to isolate those compounds, and these are like eclipse form, staggered form, and some more forms are going to exist now, like skew form, Gauche form, and fully eclipse, anti form. So many more are going to discuss when we will study this conformational isomers. And regarding this configurational isomers, if you see over here, so they can be isolated, and they are again of two type, due to the restricted rotation, the 3D orientation difference due to the restricted rotation, and 3D orientation difference without the restricted rotation. So this restricted rotation we will see this Cis-Trans, alkene, alkyne, and cyclohexane compound, different orientation. And regarding this optical isomers, enantiomers and diastereomers. So these enantiomers are generally RS configuration, or you can say non-superimposable mirror image. These enantiomers are non-superimposable mirror image. These enantiomers are non-superimposable mirror image of each other, and regarding these diastereomers, they are not mirror image of either. They are not mirror image of each other. So this is the way how we can I have just give you a brief about all those isomers which we are present in the stereoisomers on the basis of this classification, just to make you understand how different isomers, just to give you a brief idea about all those stereoisomers. In the upcoming lecture, we are going to discuss all these stereoisomers such as configurational, conformational, like diastereomer, enantiomer, cis-trans, EZ, anti-syn, all those stereoisomers we are going to discuss in quite detail. So be continued with this series so that you understand all the concept with better understanding. So in the next video we will discuss regarding this restricted rotation compound or geometrical isomers. So that's all for today. Thank you.